You put in your earbuds, tap one button, and suddenly music is in your ears. No cable, no obvious connection, no visible machine in the middle making it happen. The same thing happens when a keyboard talks to a laptop, a smartwatch talks to a phone, or your car picks up your music the moment you turn the engine on. It feels so normal that it is easy to miss how strange it really is. These little devices are finding each other, recognizing each other, and sending information through the air in just a few seconds. So what is actually happening? How does a pair of earbuds know which phone to connect to? Why does Bluetooth work well for some things and not others? Why does it sometimes cut out in a crowded place? And how can so many devices share the same invisible space without everything turning into chaos? In this video, we are going to break that down simply. Because Bluetooth can feel like magic when it works, but it is really a carefully designed, short-range wireless system built to connect nearby devices quickly, quietly, and with very little power. The first thing to understand is that Bluetooth is not the internet. It is also not the same thing as Wi-Fi. Bluetooth is mainly designed for short-range connections between nearby devices. That is why it works so well for headphones, speakers, watches, keyboards, fitness trackers, car systems, and other gadgets that only need to exchange information across a small distance. At a basic level, Bluetooth works by using radio. Your phone has a small Bluetooth radio inside it. Your earbuds have one too. When Bluetooth is turned on, those radios can send and receive information through the air using the 2.4 GHz band, which is a common part of the radio spectrum used by many short-range wireless technologies. That is the invisible space Bluetooth lives in. And that brings us to the first hidden trick behind the system. Before two devices can really work together, they usually have to notice each other first. This is the discovery stage. One device may announce that it is available while another scans the area for nearby devices. That is why your phone can show a list of headphones, speakers, or watches nearby. In simple terms, devices are saying, "I'm here," and other devices are listening. Once the right two devices find each other, the next step is pairing. Pairing is more important than just connecting. It is the step where two devices establish trust, exchange the information needed to recognize each other again later, and set up a more secure relationship. That is why you sometimes see a pairing request, a confirmation code, or a message asking whether you want to connect. The devices are not being overly cautious for no reason. They are making sure they are talking to the right partner and not just any random device nearby. After that first pairing, the relationship usually becomes much easier. Your earbuds can reconnect to your phone automatically. Your keyboard can wake up and start working again without asking for permission every time. That convenience comes from the work the system already did earlier. Once the connection is established, the devices can start exchanging data. Exactly what kind of data depends on the devices involved. Sometimes it is audio, sometimes it is a small control signal like a key press from a keyboard. Sometimes it is health information from a wearable device. Sometimes it is just a status update like battery level or location. What matters is that Bluetooth is not trying to do every wireless job in the world. It is built for short-range, relatively lightweight communication between devices that are close to each other. This is also why Bluetooth is not just one single mode. There are two major forms most people indirectly encounter: Bluetooth Classic and Bluetooth Low Energy. Bluetooth Classic is the version many people know from wireless audio speakers and car systems. It works well when a device needs a steady connection for something like music or continuous communication. Bluetooth Low Energy, often called Bluetooth LE, is built for devices that need to use much less power. That is why it shows up so often in watches, trackers, sensors, smart home gadgets, and other small battery-powered devices. That difference matters because a smartwatch and a pair of wireless headphones are not trying to solve the same problem. One may need to exchange small amounts of data for long periods without draining the battery. The other may need to carry audio continuously in real time. Bluetooth has evolved to handle both kinds of jobs. Now here is one of the cleverest parts of the system. Bluetooth does not simply sit on one radio channel and hope nothing interferes with it. Instead, it jumps around. This is called frequency hopping. In plain English, Bluetooth rapidly switches among different channels inside the 2.4 GHz band while communicating. That means the connection is constantly moving around rather than depending on one narrow frequency the whole time. This helps a lot because the 2.4 GHz band is busy. Other devices use it too. Some Wi-Fi networks use it. Other wireless gadgets use it. In a crowded room, that radio space can get noisy. Frequency hopping helps Bluetooth avoid getting stuck in one bad slice of the spectrum. You can think of it like walking through a crowded space and constantly adjusting your path instead of trying to force your way straight through one blocked lane. That does not make interference impossible, but it makes the connection much more resilient. And that helps explain why Bluetooth can work so well in normal life, even though the radio environment around you is often messy. Still, Bluetooth is not perfect. If you've ever had earbuds cut out in a busy train station or a Bluetooth speaker stutter when you walk too far away, you have already seen the limits of the system. Bluetooth is short range by design. Range depends on things like signal strength, obstacles, walls, people, and the amount of interference nearby. A device may work beautifully across a room and much worse through several walls or in a crowded area full of wireless traffic. That is not because Bluetooth is broken. It is because Bluetooth is making trade-offs. It is designed to be convenient, low power, and small scale. Those strengths are exactly what make it so useful, but they also mean it is not meant to behave like a long-distance, high-power wireless system. This is also why Bluetooth can feel different depending on where you are. In a quiet room, the connection may feel almost perfect. In a crowded airport, a gym full of wireless devices, or a pocket blocked by your own body, the signal may have a harder time. Distance matters, obstacles matter, the surrounding radio environment matters. So, when Bluetooth cuts out, the problem is not always dramatic. Sometimes it is simply the physical reality of short-range radio trying to do its job in a noisy environment. There is another part of Bluetooth that people rarely think about, and that is security. Because Bluetooth feels casual, it is easy to forget that it still creates a wireless link between devices. That is why pairing matters, and that is why modern Bluetooth connections use security features to help keep the link private and trusted. Without that, connecting devices would be much riskier and much less practical. So even though Bluetooth feels easy on the surface, there is a lot going on underneath. Discovery, trust, channel management, power control, and data exchange, all happening quietly in the background. And once you step back, the full picture becomes much more interesting. Bluetooth is not just the thing that connects headphones. It is a shared wireless language that lets nearby devices discover each other, create trusted relationships, and exchange information without cables. It has become part of the invisible fabric of everyday technology. A watch tapping a phone, a car connecting to music, a keyboard sending keystrokes, a fitness tracker updating an app, a wireless speaker receiving audio across a room. All of that depends on the same basic idea: small radios, nearby devices, and a communication system designed to be good enough that you hardly notice it. And that is what makes Bluetooth such a perfect hidden infrastructure topic. It feels small and personal, but it is built on a global technical standard. It feels effortless, but it depends on careful design choices around radio behavior, security, power, and interference. It feels like magic because the system was designed to get out of your way. So the next time your earbuds connect in a second or your car picks up your phone without a cable, it is worth remembering what is really happening. Two nearby devices are discovering each other, recognizing each other, hopping across radio channels, and exchanging information quickly enough that the whole thing feels invisible. That is how Bluetooth actually works. And like so many hidden systems, the better it works, the easier it is to forget how clever it really is. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.